If nothing else on this topic, then we can move on to the next one, which is about the nature of quantum probabilities. Are quantum probabilities objective propensities or subjective beliefs? Matt, perhaps you can start with a short answer.
My answer is that all probabilities are subjective probabilities, 100%. I don't believe in any of the other kinds. I think they're all conceptually incoherent.
A very strong position. Marcus.
I think they can be both. I think there can be coherent ways of talking about an objective notion of indeterminism that's more than just saying everything is possible.
Okay, Matt, do you want to elaborate on your answer?
Yeah, I mean, there's a lot that I could say because of course the philosophy of probability, even beyond quantum theory, is a very deep and controversial subject, right? And so usually people recognize at least three kinds of probability. I'd probably recognize more conceptually, right? So people talk about, okay, there has to be some kind of objective probability, there's some kind of epistemic probability, and there's some kind of subjective probability, and then we have to sort of find ways of cashing those out in terms of theories of what these things actually are. So obviously there's the subjective Bayesian approach, which I like many aspects of, not necessarily all aspects of. There's various kinds of frequentism. There's algorithmic things which are connected to frequentism but not exactly the same thing. There's objective chance theories like Humean ones like Lewis liked, and then there's sort of propensity type interpretation. There are all these things floating around. Now, what I basically find is that when you get into these things enough, you find there's something about them that really doesn't make sense, or just doesn't do the job that a interpretation of probability is supposed to do. Let me just give you one example. So, the idea of a propensity is a very popular way of understanding what's going on in quantum mechanics. The idea is that you have the quantum state, and it has a propensity when you make a measurement to give one answer, or a disposition to give one answer to a certain extent and the other answer to another extent. So it's describing sort of potentialities when you make a measurement. And you say, okay, well, does that make sense of probability? Can I say that that's what the probabilities are? But then you realize that you can't make sense of backward directed probabilities at all in that context, right? So I can say, when I make a measurement in the future, I have a certain propensity to do this, that, or the other. But you can't say, given that they got this measurement result, what's the probabilities for some measurements that I did sometime in the past, which of course probability theory and quantum theory have absolutely no problem with, right? So I just find, all of these things, they're trying to basically do more than a probability theory should, I think, right? So, there are all kinds of problems where if you want to say these things are like fully objective, you have to say, okay, well, why are things independent and identically distributed in our experiment so that we can make inferences and all this kind of stuff? I just find that if we just let's take a step back from that and let's say, okay, let's just start out from the point of view of subjective probabilities, which most, if not all, people agree make some sense, but they just disagree that you can talk about the other kinds of probability in terms of them. That one, at least, we have to say exists, because we do indeed make subjective probabilistic predictions. People do bet on horse races. People do have opinions about how likely things are going to happen. So I would like to start from there and then build up the theory. Right. I mean, so I could go into a lot greater detail about why specifically I don't like the other options, or how exactly I think that you should build things up. But broadly speaking, I think the bottom line is it's the only one that makes good sense to me.
Markus, you have a chance to explain your own answer.
So I think I want to follow up on that a bit. So certainly there's a lot of work and debate on the interpretation of probability. I'm sure that Matt has a much more to say about this because he's knows much more about that. Certainly, I mean, I'm not a frequentist. Yeah, I think a Bayesian approach to probability in general makes a lot of sense. But I feel somehow that to say that a notion of objective chance is in itself questionable, or that it doesn't make sense, or that it's hard to ground, I found that question begging. So because the question is what the alternatives would be. So let me illustrate this. So I think we all have a pretty intuitive understanding what it would mean to live in a deterministic universe, like in Newtonian mechanics. We're here, we kick the ball and the ball kicks back. And this is what happens and nothing else will ever happen. So somehow we understand the way that anything external manifests itself to us deterministically is something really clear. And there's no problem in thinking about the world being like that. Now, what could it mean, however, that the world is not deterministic? So, for example, the cubists sometimes say that, at least some of them, and I hope I do justice now to them when I try to represent their position, but they would say, you kick the world and the world hits back. Your quantum probabilities are just subjective degrees of belief on what you think the world will do when you kick it. Yeah, it makes a lot of sense to me to say quantum states can represent states of belief. But then they say, and actually the way that the world kicks back is indeterministic. Right? Now, it sounds innocent at first, but you have to ask then, what specifically does that mean? And I think that's a problem for all claims that the universe is indeterministic. Suppose you avoid the use of probability theory now when you talk about that. Because you may say, well, what does it mean that there's a propensity of 49.7% that the detector will click? I don't even know how to make sense of that, how to ground this notion in facts of the world or so. But then you run out of options quickly. Hey? So what then does it mean that it's not deterministic? So do you mean that it's kind of irregular? What if you do it and it's always clicking? You wouldn't call that indeterministic then. You would say it clicks always. So sometimes when you repeat it in some sense, then sometimes it won't click. But you don't want to happen it click and then not click and then click and then not click. So some might should be irregular, right? And then you can aspect, so then what is actually the content of what you say there, that it's not deterministic? And I don't know of any good ways to say that or to say anything about this rather than falling back on some notion of probability. So it doesn't have to be an actual number that you put. Right? Maybe you can have something like a set of priors, like where you essentially always say what are non-stupid initial beliefs to hold and then how should you update them. But we don't have many options to talk about a world that's not deterministic without resorting to some sort of probability. At least I don't know of any. Or Matt, actually, I'm curious what you would say about that. You've heard some possibilistic theories and things like this.
Well, I have, but I'm not sure. I mean, I am very sort of loosey-goosey on the need to use probability always to quantify our uncertainty. I actually think the situations in which we do that are very rare. If you're a hardcore subjective Bayesian, you'd say every time you have to make a rational decision, you should be using probability theory. But that would make a mockery of like almost everything that we do on a day-to-day basis. So either you have to think that humanity is incredibly irrational, which it is, but all of humanity, like everybody, even the most rational people, or there's just something wrong with that idea. But anyway, that's a sort of a bit of a side point. How do I make sense of an indeterministic theory? Well, to some degree, I don't, because I sort of think Well, what we know is that we have a probabilistic theory. So quantum theory is a theory which predicts probabilities for things to happen. Why does it predict those probabilities? Is it because there's some fundamental indeterminacy in nature, or is it because we're just uncertain of something? From my point of view, I view that as a sort of a bit of a non-question. So my point of view is really sort of what's called the sort of Humean point of view in David Lewis's terminology, right? So the metaphysics. So I believe in the block universe. I think the block universe is well founded on the basis of relativity. So we have this 4 or perhaps higher dimensional space-time that exists, right? And then within that, there are things that have happened, right? So in particular locations in space-time, or or in regions of space-time, we can say things have happened. Like there was a measurement result here, and it's such and such. And to some degree, that's what the world is made of, right? This thing is often called the Humean tapestry. Okay, so there are measurements in the future, and they have results, and there are patterns, and there are patterns. Those things all exist. We are agents located in this thing, and from our point of view, well, we only know about the past and we don't know about the future. So we talk about making predictions, and the best laws, the best summaries that we have are in terms of probabilities. So that's roughly what I would say about that. But does that mean that we're using objective probabilities? You see, Lewis in his account of this had an idea that yes, there's this thing called objective chance, which somehow is a bit like frequentism, but not exactly frequentism, because we know that would be ridiculous. It's sort of like a best fit. It's like what's the simplest theory that roughly predicts what the frequencies are to a good enough precision in the future, something like that. And he'd say that's the objective chance. I would say, if that's the objective chance, there's no way that we can ever really know that. I mean, even from the point of view of sort of Kolmogorov complexity and algorithmic randomness and things like that, that if you observe the initial segment of some string, some binary string, and it's random in one of those senses, then it could still be anything, right? Because you only have asymptotic guarantees. So if objective chances exist, I would argue that we have no access to them. All we can do is make assumptions about the regularity of the data, like things like the exchangeability assumption that you make in the Finetti's theorem, for instance, and then you have subjective probabilities. Do we have a strong reason to believe that those subjective probabilities will continue to, if we've conditioned them on data, will continue to be predictively accurate? You have no logical guarantee of that, but that's just the problem of induction, the statistical version of the problem of induction. And you can never solve the problem of induction, right? So entities just have to assume. We have to sort of wear on our sleeve the fact that we're assuming that the stuff we've seen is regular enough. We can't prove that. We shouldn't assert it because it might not be true. But we have to say that, okay, I've used that belief in forming my subjective probabilities. And then if that's the case, then we will expect them to continue to be predictive, even if at some point they might not be. And of course, in general, they aren't, because we do find that theories get overthrown by new theories, and maybe that process is never ending. So I mean, that's roughly how I make sense of it. And from that point of view, does it make sense to think that the world is fundamentally deterministic or deterministic? Well, not really. It's sort of a 4-dimensional picture to begin with. It's not a picture of something existing at a time and then evolving, forwards. And so we're talking about, is the future determined from the past? Well, I mean, we just live in a 4-dimensional block universe, that those kind of questions aren't really that relevant, I would say.
Yeah, it seems so. I mean, it seems. I think I would like to be a bit careful between, say, ontological claims about what it means to talk about, say, objective probabilities or objective chances, and structural claims that arise from it. So, for example, you could say, here's what I mean by quantum probabilities being objective chances. So I don't know how to ground that in the ontology of the world, because maybe if I want to talk about the ontology of the world, I have more reasons to talk about the block universe, like math does. But I can ground it on empirical findings. Like, for example, quantum theory allows me to build these devices that generate bits, which people are willing to buy a lot of money, believing in nobody being able to predict those bits, right? And even the formalism of quantum theory predicting in some cases that the bits that are shown by this box later in the block universe are in some formal way uncorrelated with other bits, right? Like that of eavesdroppers who want to rob the casino. So, it's just two different things. Like one of them would be to say, I'm skeptic whether the world is such, like the most fundamental like flaw of reality, like what's actually there, whether that admits a notion of objective chance, or whether you say, the notion of objective chance is a better description in many cases rather than using a notion of epistemic or of belief, because, for example, it predicts this thing that nobody else can know it. Nobody else can predict it. Whereas if it's really just my belief, then there's no reason a priori to think that no other entity could know the result already. And I tend to be a structuralist. So every claim I make about the world, I want to ground in sort of, say, maybe it's operational content or it's mathematical content, how you would actually define it if you try to be as explicit as possible. And yeah, that's why maybe some of the disagreement comes from, because I think I don't really care that much about whether we should really think of like God throwing dice or so.
Yeah. So let me think about this. So I mean, I certainly think that there are a lot of situations in which you certainly do no harm if you think about things in terms of objective probability, right? And a lot of of situations in physics, in fact, sort of the typical situation in physics is like that, a lot more so than it is in other subjects, because compared to other subjects, certainly, in areas like quantum optics or whatever, we're drowning in data, right? People doing medical trials would kill to be able to do the number of trials that we can do in physics, because we're dealing with inanimate things that doesn't really affect anything. So that's a regime where usually thinking in terms of objective chance isn't going to lead to problems. So from that point of view, I have no disagreement with that. But there is to go to this sort of cryptography claim that we can generate random numbers that no eavesdropper can know about. Right? That is a claim that follows from quantum theory. So it is basically a form of cryptography that's backed by the laws of physics. Prima facie, before if you don't know anything about quantum information or whatever, that's a weird claim, because it previously looked like all claims of randomness and computational complexity and based things were based on the foundations of mathematics rather than anything else. And it takes a bit of thinking to reveal that actually the laws of physics make sense. Now you might say, okay, well, Turing machines and whatnot were based on thinking about the physical process of doing computations, but actually they weren't based on that much about the physics, right? Classical physics could have been changed in all kinds of ways. The move from special relativity to general relativity doesn't really affect the theory of computation, for instance. So it's weird. Now, do you need an objective chances? So first of all, I think that we should keep in mind that when we make a claim like that, it is a claim that's backed up by the laws of physics. And if the laws of physics were to change in certain ways, that claim would no longer be true. An example, I keep bringing up the same thing. I don't want to make out that I'm a strong advocate of this, but again, non-equilibrium de Broglie theory would say that if you have access to non-equilibrium systems and you could bring them in and interact with the system you're using to generate this randomness, then the eavesdropper could use that, in fact, to find out the values. So it does depend on the laws of physics, and it's not like necessarily a fundamental fact that has to be preserved. It also, to some degree, doesn't matter. Well, I also want to say, I want to bring up something here, which is that years ago, the cubists, this was, prior to the split into the highly subjective sort of Fuchs camp and the, Carcave's camp of being sort of more still objective about Bayesianism. But Caves and Shack had a paper that they never published on a concept called inside information. And this was, I'm not entirely sure why they abandoned it, but it was a way of making sense of the cryptography claims from a subjective Bayesian point of view about probability. So I believe that can be done. There must be a reason why they weren't really satisfied with it, but when I look at the sort of draft paper, I don't see anything strongly wrong with it. And nonetheless, in sort of my four-dimensional sort of block universe type of approach, Humean tapestry type of approach to things, those cryptography claims are again true if it turns out that an agent who is located within that universe and has access to restricted information, can't see the whole four-dimensional tapestry. An eavesdropper like that, assuming that quantum theory is our best system for that, isn't going to be able to predict those random values. So we can make sense of that in a variety of ways. I'm not sure it requires objective chance. It requires a notion of understanding how something can be hidden from somebody else in situations of uncertainty. That may have been a vague answer, but I'm just what I want to do is, I think that there are lots of times where people say, okay, look at this phenomenon. Surely we need objective chances or objective probabilities to make sense of what we're saying here. And usually it just turns out that we don't. And usually also I think that thinking about why we don't leads to some progress too. So I remain unconvinced that it's needed anywhere. And I also remain convinced that any attempt to cash it out, usually ends up just not working.
Yeah, I mean, I agree that it's probably not needed. Question is whether it's useful. Like what you want to decide to use as like the notions on which you ground the way you talk about the world. But certainly, I mean, I agree with you that whatever notion of objective chance we come up with, when you just ask, what does it for us? Then you can always ground it on other notions of probability. You can be a subjective Bayesian, I think, then you say, okay, now if I have a large number of agents that have done many experiments and due to Bayesian coherence have come to posterior beliefs that are very close to each other, and then they all agree that they assign a probability very close to 1 for this and that event, or probability P in some certain situation, or where you have like exchangeability, then you can probably cook up, certainly, I mean, it seems obvious that then you can cook up situations where the notion of objective chance arises as a good approximation in the sense that this actually, which is actually not objective chance, but has all the properties that you would objective chance want to have. Right. So I fully agree that you can probably do without it. I felt like still I'd find it sort of unmotivated to try to avoid it at all costs when you think about fundamental physics.
Oh, okay. Here's one of the reasons why I do take that point of view. Well, here's one thing that physicists do like: unification, right? So generally, we think that theories that explain more, theories that can explain more from a single set of assumptions that unify phenomena are better than theories that don't. Whether that's really an epistemic virtue, we can argue about, but it's certainly something that we tend to like. Then you look at something like the theory of probability. So the theory of probability has a single set of axioms. We agree, roughly speaking, although there's some debates, but we agree, roughly speaking, take the Kolmogorov axioms for probability. Everybody agrees that's the right theory. Okay. And then you look at the foundations and you say, okay, here's one mathematical theory, a single mathematical theory that's described in exactly the same way. However, there are subjective probabilities, there are epistemic probabilities, there are objective chances. And by the way, these are all different theories, right? The way that we reason about them, the way we think about them, the way we think about what they are is completely different. And, you can also determine that if there is any such distinction, it's a fuzzy distinction, right? So, for instance, if I just say the statement, there's an 11% chance of rain tomorrow, whether I'm just an ordinary citizen as I am, just like making a casual comment, or whether I'm a meteorologist who has run simulations, determines the degree of objectivity of that statement, right? It need not be entirely a subjective statement or entirely an objective statement if such a thing exists. There's sort of a continuum. If I say, I'm going to a party tonight with my wife, and there's a 30% probability that she'll wear a red dress. It's very likely that that's just a subjective statement, my feeling. But I might have also observed every single party we've gone together and written down, what color dress she wore and be basing it on frequencies. Or I might, so the thing is these distinctions are definitely fuzzy. There's a fuzzy middle ground. And that's okay, right? Just because there's a fuzzy distinction, most distinctions that we make in philosophy, turn out to be fuzzy, right? So long as there are cases where it's sort of clearly one thing or clearly the other, it doesn't matter so much if there's a fuzzy middle ground. However, there's something curious about this one. When there's a fuzzy border between two things, it's usually the case, however, that the mathematical theory on those two sides is different, right? The theory of, let's say, this is going to be a controversial one, but an inanimate object versus a conscious object, right? Those are very different. We don't use the same terms. We don't use the same mathematical theory to describe them. The theory of a pile of a few grains versus a mountain of grains that can have avalanches, we use different mathematics for. This is the only case that I know of where there's this fuzzy distinction. These things are really very distinct from one another, and yet we use the exact same mathematical theory, the exact same mathematics, no difference whatsoever. And that indicates to me that these distinctions can't possibly be distinctions, right? It would be more explanatory to have a unified theory. And if we have a unified theory, it has to be the subjective one, because it's hard to ground first person notions in objective notions, as you obviously realize, Marcus. It's hard to just start with the objective notion and say that everything derives from that, but it's easier to sort of explain the appearance of apparent objective things from the point of view of starting with the subjective notion. You sort of have to start with the weakest notion that can support the theory, and that is the weakest notion. Now, obviously, there are things like Lewis's principle, which claim to show why objective chances have to obey the same mathematical theory. But I also personally, and this is going off on a bit of a tangent, don't believe that subjective Bayesian probability theory always applies in all situations of uncertainty. So if you accept the Lewis principal argument, then you also have to accept that there are situations in which objective chances aren't described by probabilities, and probably fewer people are willing to accept that than they are on the subjective side. So from to my point of view, it is way simpler to just say there's one kind of probability, this is it. Let's try and use that explanatory framework to derive everything else. No, I may be wrong about that, but that's basically so. So I'm arguing from the point of view of simplicity. You're arguing from the point of view of, well, these concepts are useful. You know, having a simple theory which has a few basic postulates, to me, that's more useful. So it's kind of where I'm coming from that.
Yes. Okay, so let me follow up on this. I think I have a lot of sympathy for what you say in general, but I want to like push back a bit on it and challenge this a bit. So think, for example, of the concept of the real numbers. Right? So it's a really beautiful concept, and to make it mathematically rigorous, you really have to work a bit. Yeah. You introduce the rational numbers, then you complete them by looking at equivalence classes and Cauchy sequences and whatnot, and then you arrive at the concept of real numbers. Now it turns out this concept describes temperature in physics, it describes length, it describes mass, the exact same structure, but these things are still different, right? So I don't see right away that the fact that we have this one structure, the Kolmogorian axioms of probability theory, why that would motivate the conclusion that we have actually only one kind of that thing in the world. There's actually, but I do like this kind of thinking that you put forward here. So let me put it a bit further into something that I've been wondering about for a long time, but nobody else seems to wonder about it. And that's when you look at probability in physics, then probabilities have linear structure. For example, you know, when you toss a coin and you prepare a state with 50% probability, either one state or the other, you can write it down as like 1/2 times state 1 plus 1/2 times state 2. So you can think of like statistical mixtures as giving you a mathematical notion of something like linearity. Now, you have linearity in many different places in the world. You also have linearity of vectors. So when you have velocities v1 and v2, and you can add them up, v1 plus v2. So like there's a train moving, but on the train there's a car moving. Like what's the velocity of the car with respect to the ground? We'll add up the velocities. Now, interestingly, actually in quantum theory, what you have is representations of groups, which tell you something like, oh, when you rotate in space, you rotate the vectors, which is a linear operation. There's a one-to-one correspondence to a linear operation on Hilbert space, right? So this weird notion of probabilities, no matter how you ground it, which seems very far removed from any notion of linearity in like for vectors, is somehow connected to it. There's like a structural bridge between these two seemingly very different things that talk to each other. So this and the example of the real numbers makes me believe that there can be a single structure having many different inequivalent instantiations in physics, and they may even talk to each other. Like maybe my beliefs should be aligned with whatever the objective chances are, or vice versa. Yeah. So I think that do you think this could be a counter argument to your?
Yeah, I mean, I think
argument?
I need to clarify a bit what I meant when I said that these different types of probability obey the same theory. So, I mean, you're right. There's a sense in which probability theory, the Kolmogorov axioms, are a mathematical theory, right? You know, roughly speaking, you have a bunch of numbers that are positive and sum to 1, right? I mean, obviously more to it than that.
Right.
And there are obviously many things that obey those axioms. So, for example, I could say, right, that suppose the moon were made of cheese, and it were made of different types of cheese, like gorgonzola and cheddar and also all sorts, right? And I say, well, what's the relative proportion of those types of cheeses on the moon?
Right.
That would be a set of numbers that are positive and add up to one.
Right.
If I were to then assert that the probability when I flip a coin on the Earth here is determined by the proportion of a certain type of cheese on the moon, that would not be a good theory of probability, right? So there's a difference here, because when I'm talking about a theory of probability, what I'm talking about is the theory that underlies our assertions about reasoning in the face of uncertainty, right? So in that sense, it's uh, it's sort of a normative theory about sort of the logic of reasoning, logic of reasoning in the face of uncertainty. It's or you know, if you believe in some kinds of objective chance, you'd even might say it's a kind of physical theory. So I mean more than just the mathematical structure. I mean the whole set of fundamental postulates that undergirds our use of probability theory and statistics, to make assertions about what's likely to happen in the world. So in that sense, I think it's unlike the theory of real numbers, because that is a sort of abstract mathematical structure that, as you say, is useful in a variety of contexts. There are many things that appear to at least approximately model it. Whereas here we're talking about, you know, different theories that are supposed to guide our reasoning in the face of uncertainty. Like if the objective chance is such and such, and I know it, according to Lewis, that needs to be my subjective probability. That should be that should determine how I bet. And the question is, why is this structure determining things like that? So that's why I view it as different from, it's not really the Kolmogorov axioms per se, but it's the whole apparatus of sort of understanding why we must reason in the face of uncertainty according to probabilistic and statistical procedures. So I hope that makes sense. The example of groups, I think this is great, because obviously it is the case that, you know, so if I was a pure subjective Bayesian in the kind of way that the cubists seem to want, then I need to say there are never any constraints on prior distributions whatsoever. But I don't actually believe that. I do believe that there are theorems which say that if your belief is structured in such and such a way, then you must assign probabilities in a certain kind of way. So I do believe you could make some kind of argument that if you have a belief in some physical symmetry, then you would assign a probability that reflects that. Okay, so this is where like groups and representations would come into the physics, and I believe that if you know, I don't think anybody has done, even the cubists have really done a reconstruction of physics, including things like thermodynamics, in where we have purely subjective Bayesian probabilities. Seems like a hard task, because you need to say things like what's special about the, canonical distribution in thermodynamics, etc. And if you have a prohibition on ever saying that a prior has to be anything in particular, then you have nothing to say other than, okay, we did a lot of experiments and did Bayesian updating and ended up there. But that is obviously not how we arrived at that. That would be a cartoonish thing to say. So I do believe we have to make sense of that in subjective probability theory. I believe that's missing. But I do also think that we can make some sense of symmetry principles and use those. But we have to be very clear that what we're not using is the principle of indifference. We're using the principle of indifference is if you have no reason to think that you have no information that X is different from Y, then you should assign them the same probability. This is different. This says if you have strong reason to believe that X and Y are connected by a symmetry, so it's a positive statement rather than a negative statement, then perhaps their probabilities should be related. So that kind of thing, I think you can make work with subjective Bayesian probability, at least the sort of revised version of it that I like to talk about. So I think that is very important, and I think can end up again explaining from sort of theoretical point of view. Then there's sort of like the empirical view on objective chance and the theoretical view, right? So you have these theorems that say, okay, if a bunch of people all have reasonable but differing priors, and they all collect a bunch of data, they'll end up agreeing, and so that roughly gives you the amount of objective chance. But you also have, on the other hand, there are arguments based on just the theory of the physics that you should assign such and such probability distribution or another one. And I think that we need to be able to make sense of those kinds of arguments as well, like theoretical arguments. I think it hasn't been done, but I think it can be done, and that needs to be done in order to make the kind of theory of probability I'm advocating like really make sense.
Yes, I think I agree. I just want to clarify that I didn't put up symmetry to argue for a kind of principle of indifference as a sort of necessary objective element of your probability assignment. Right? That I agree with you that it's not a priori clear. So you need other reasons that tell you why things that are related by symmetries in the end will have the same probability or so. But I agree with what you say. So it seems to me, when you said both subjective beliefs and objective chances would refer to like how we act in the presence of uncertainty, you could still say, well, subjective beliefs are how I actually act, whereas objective chances would be how I should act, right? So it's probably a priori it refers to the kind of same like corner of experience in the world. Like we face uncertainty, have to do something, but there might be nuances that make room for two versions of this, right? But yeah, maybe that's going too far.
I mean, I don't know. I think that people normally think of subjective chances in normative terms, in terms of like what you should do. So, and then they think of objective chances in terms of, I guess, if you want to say what's their effect on, if you say what's their effect on actions, then you'd have to say it's what you should do in the context where you have access to all possible relevant information, and that's the kind of thing that I'm wary of. But anyway, I think we've probably digested this subject.
Yes, that's right.
Agree now.
Next topic is to ask you whether you think the following statement is true or false. There are scientific claims that can only be verified privately, but not intersubjectively. I guess, Markus, would you like to give a short answer?
Yes. Yes.
Yeah. No change of mind since the last episode. What about you, Matt?
I'm going to hedge a bit and say probably yes. Yeah. It depends. It depends on the status of consciousness to some degree.
Right. Markus, would you like to elaborate on your idea? Sorry, on your answer.
Yeah. Okay. I mean, the example that most people might have in mind now is certainly, as Matt said, something related to consciousness. So you might think of a world that's physically equivalent to ours, as seen from a hypothetical third-person point of view, but where, for some reason, all humans are zombies. They just look as if they're conscious. They claim they're conscious, but they are not really. Now, I'm just saying this because that's an example we typically have in mind, or some of us have in mind. There's a big debate about whether the notion of zombie makes sense at all, and I don't want to go into this because I'm thinking of examples that don't have to do directly with consciousness. I want to think of instances of the question, what will happen to me next? So I think this is a question that does not in all instances have an answer in the sort of theories that we have, partially because there are instances where the potential answer is just not intersubjectively verifiable. So with that, I mean, for example, we have standard situations where you can ask this question, like, I go into the lab here in the basement of Ikoki, I see a certain arrangement of lasers and of mirrors, and then I ask myself, will I hear a detector click, yes or no? I can use quantum physics to obtain a prediction for that. It's typically not deterministic. It often comes in the forms of probabilities. There are ways we agree on for testing these probability assignments. We can think of, at least in principle, repeating an experiment many times and see if up to some, statistical significance we find the expected frequency, perhaps, or not. But there are situations where I think that this is blocked, where this is impossible. And an example, so there are examples like things that have been discussed in the philosophy literature. So, for example, somebody duplicates you, right? And you have this teletransporter thought experiment by Parfit and so on. So somehow, you suddenly there are two copies of you, and maybe you know that this will happen in the next moment. Then you may wonder, how should I think of this? What should I believe to experience next, if anything at all? Now, from a third-person perspective, there's nothing to ask. All there is to be said from a God's eye view from outside is that there is one Ding Jia right now, and there'll be two instances that claim to have been Ding Jia, like in the moment afterwards. But still, you may wonder, like, if this actually happens to you, I think you couldn't stop wondering how you should think of this. Similar thing about computer simulations of agents. So all these science fiction scenarios that are now science fiction, they may not remain science fiction forever. And I think that these are instances where we cannot simply look at the physics of the setup, what's the computer builds from that's simulating you in the next moment. What is the arrangement of atoms that make up your experiment? It's a sort of a different kind of question, would be a category mistake to like ask physical theory as we have it now to give you the answer from this arrangement of things in the lab. Finally, I think this is related to, in physics, it shows up in terms of the Boltzmann brain problem, where we say, well, perhaps we can use a certain type of reasoning to constrain our cosmological model. Namely, if I have a cosmological model where there are somehow very many unlikely copies of me out there, and then if so, what should I expect to see in such a situation if this were the case? If there's an actual answer to that, that would be that I should have. So perhaps I should sort of assign, like Elgar argued, a principle of indifference. Then this predicts things that I don't actually see, and maybe I can rule out this cosmological model. Or finally, Wigner's friend, I think, is another instance where, at least insofar as you want to say that you want to talk about the probabilities of the observations of an agent, then whatever this probability is supposed to be, it cannot be derived from a joint probability distribution of the observations of all agents. So I think these are instances, perhaps of different sorts, but structurally related, of this question, what will happen to me next, that cannot in principle be answered by the way we use physics now.
Yeah. Okay. One thing I want to say is that this question, what will happen to me next, is to some degree connected to questions of consciousness, because we have to understand the meaning of the term me, and that sort of. So we normally think of me as being the self being sort of this connected stream of consciousness. So, and some of the examples you gave are do have to do with consciousness. So, one thing I would say though is that one of the questions you gave was very simple to answer. It's a question of do philosophical zombies make sense? My answer to that is yes, they definitely make sense, and we definitely have them in our world. For example, there are people who believe in physicalist theories of consciousness. Now, when I open my eyes and experience what it's like to be me and see things from behind my face, uh, I experience the qualia. It is immediately obvious, requiring no logical argument, that it would be impossible to derive that fully from physics.
Fully
So,
agree.
if there are people who believe it's possible to derive it from physics, they cannot be having the same experience as me. Therefore, they're philosophical zombies. So, I'm afraid
I think
that
I fully agree. Yeah.
Sean Carroll is a philosophical zombie, must be. Daniel Dennett was. Those people, they must be philosophical zombies because otherwise there's no way they could believe that. There you go. Proof. Empirical proof. But, but I do think, so obviously the straightforward examples like, it is either a fact or not that I'm experiencing the qualia of red or whatever, right? And the only way that can enter into like a scientific theory presently is via, a report, right? I report that I'm experiencing red, but then again, we have the problem that that can't really be verified because, if we believe that it's possible to have philosophical zombies, then that's not a way of verifying that claim. However, we could have scientific theories of consciousness which can be sort of confirmed individually just by introspecting our own experience, multiple times on multiple occasions. There could be a theory out there that says predicts what the experience would be if you do such and such a thing, and you go and do that thing to yourself. You have that experience. A bunch of other people do it. They also confirm it. So it wouldn't really be confirmable in the sort of third-party sense because you can't really trust reports, although most of the time we're probably likely to believe them. So in principle, I also agree with Marcus that, certain situations that come up in physics, like in many worlds type of situation. So the duplication machine, if you believe in the many worlds interpretation, then you believe that we do actually have such a duplication machine. It's called making a quantum measurement. And so the question of what will happen to me next arguably doesn't make sense in that situation, and that's highly related to the question of probabilities in the many worlds interpretation. And again, in quantum physics, I agree about the Wigner's friend thing. So particularly in extended Wigner's friend experiments, which we have talked about in the previous episodes, that seems to be a situation where if you take the Neo-Copenhagen route, and let's admit that you don't necessarily have to take the Neo-Copenhagen route, but if you do take the Neo-Copenhagen route, the most sensible way to talk about those experiments is there are situations where there are facts for one agent that simply do not exist for other agents. So, that agent can confirm what the outcome of their measurement was, but that measurement outcome just doesn't exist for the sort of Wigner type of character. So, I mean, we can still say things about what we expect for that person to have seen, but, and that's based on, there's a sort of a bit like the question of, okay, if you send somebody into a black hole, right, then they will learn what it's like to get sucked into a black hole, but they won't be able to communicate that back to us. So in some sense, that is another example like that. However, the reason we believe that we know what happens when you get sucked into a black hole is because we have the theory of general relativity, which is very well confirmed in other circumstances. So you have good reason to believe it, even in circumstances where, strictly speaking, you can't, do a third person kind of test. Same is sort of true here, right? So, in the Wigner's friend experiment, you just sort of assume that quantum mechanics holds because you have very good reason for assuming it holds in other circumstances. You can't, strictly speaking, prove it must hold in this circumstance. They have good reasons to believe in it. So you can make predictions, just you can't really confirm those predictions. There's sort of funny example where the friend can certainly make a prediction and has an experience. Wigner can make a prediction, but could never confirm it because the item of data just doesn't exist for him. So it's a weird situation, but in some sense, the basis for believing in that situation is a whole bunch of other data that confirms the theory. In the case of consciousness, I think it's a bit different because we don't have that common sort of underlying framework that everyone believes in on which to base our conclusions. So I think to some extent the consciousness cases are stronger.